Guys, I thought I should talk about capacitors today. We got few capacitors here. I will show you how to charge these capacitors and how does it work, what it's used for, stuff like that. We're going to connect these capacitors in series in a circuit. We will see that. Then we will connect this in parallel. Then we will see some equations. I have a capacitor, this yellow one over here. This is a 6 volt 22 microfarad capacitor. If you look at this, you can see a negative marking on this one, and there's a pin close to this negative marking is the negative pin of the capacitor, and the other pin is the positive. This is a bigger one. This is like 4700 microfarad capacitor, 16 volt. This was 16 volt too, but it's 22 microfarad. A very little capacitance compared to this one. This is a 4700 microfarad capacitor, and this one is like a bigger one, bigger than that one, the 6800 microfarad capacitor. All of these are electrolytic capacitor. I want to show something else. You have probably seen capacitors like these. These are called polyester capacitor. It doesn't have electrolyte in it, but this one has some kind of liquid in it. This is completely dry. Two metal plates separated by a polyester material. That's what it is. This one is two metal plates separated by some kind of insulator. Actually, it's a kind of insulating coating, but it also has some kind of electrolyte in between those two plates. And you also might have seen capacitors like these or these, or something like this. These are called ceramic capacitors. Two metal plates separated by some kind of ceramic material. You can see some kind of numbers, which is the capacitance. Instead of writing the capacitance in microfarad, it shows some code. This 104 means 0.1 microfarad. 102 means 0.001 microfarad. There are specific code for that. I'm not going into that. Let's connect this capacitor to a battery, especially this one, bigger one. It's easy to show how it works. So I'm going to connect this to a battery. We're going to charge this capacitor. Charging a capacitor is quite easy. You basically connect the negative pin of the capacitor to the negative pin of the battery. I mean negative terminal of the battery, and the positive to the positive of the battery. You can see it's 16 volt, so the maximum voltage that we can apply to this capacitor is 16 volt. We don't want to charge this capacitor beyond 16 volt. That may damage the capacitor. So I'm using a 3 volt battery, so we will just charge the 3 volt. For that, connecting this to a breadboard. Okay, let's put a wire there like that. Then connecting another wire, the same column like that. Then I'm connecting the negative to the ground and the positive to the red wire like that. Then I'm charging this capacitor. It's quite easy, connecting the negative terminal to the negative pin to the negative terminal of the battery, and the positive to the positive terminal of the battery. This capacitor will charge instantly because there is no resistance involved in the circuit. I mean, of course there's a resistance, some kind of involved, but we don't see any resistor connected in the circuit. So now this capacitor is charged. It will take only a fraction of a second to charge this capacitor. If it is not discharged, we can discharge this capacitor using an LED or any kind of load. So what I'm doing, I'm using this red LED, connecting the anode or the positive pin of the LED to the positive of the capacitor, and negative to the negative of the capacitor. You saw the LED turned on, it's glowing, it's still glowing. You can't no, it's turned off completely. So you saw it's initially it was very bright, then the brightness went down exponentially, very fastly, to 0. So that's how the capacitor charge very fast, and it will discharge very fast. It's like it's not linear with time. It charge and discharge exponentially. It's very fast in the beginning. It will charge very fast in the beginning, then it will charge little by little by the end. Same, when it discharged, it's discharged fast in the beginning, then it will discharge very slowly when it came to the end. What I want to do now, I want to connect another capacitor to it in parallel to increase the capacitance. What I did, from the negative terminal, I put another wire over there, and from the positive terminal, I put another wire over there. Then I'm connecting another capacitor of the same value. This one is same, 4700. I'm connecting the negative to the negative terminal and positive to the positive terminal. So now I connected two capacitors. It's in parallel, which means I increase the total capacitance of the circuit to double. Whenever you connect two capacitors in parallel, the effective capacitance will be the sum of each capacitor. So this is 4700 and 4700. So 2 times 4700 would be the total capacitance of the circuit. So now the capacitance increased and it's doubled. Now I want to charge this capacitor to 3 volt using a 3 volt battery, just like that. Connecting positive to the positive and negative to the negative. Now the capacitor charged, and it has more charge in it, which means the LED should last longer. It will stay on longer than when we use just one capacitor. So connecting negative to the negative, positive to the positive, you can see LED is staying on for long time. Now because the capacitance is double now. So that's how you charge a capacitor, quite easy. But what happens if I connect these two capacitors in series? The thing that's going to happen, the effective capacitance will be decreased. So these are the same capacitance. Two capacitance are of these capacitors same. So if we connect this in a series, the effective capacitance will be halved. So this is 4700 and 4700. If I connect these in series, the total capacitance will be half of 4700 microfarad. So when you connect two capacitors in a series, what you have to do, you have to connect the negative pin of the one capacitor to the positive pin of the other capacitor, like that. Then you leave one negative pin for the battery and the one positive pin for the positive terminal of the battery. So let's connect these in series. What I want to do, how can I connect? Let's put a jumper wire like that. Then I'm connecting negative at one side, and I'm connecting the positive to this side, positive side of the capacitor. Then I'm connecting the second capacitor's positive to the negative of the first capacitor. And connecting the black wire to the negative side of the capacitor. Like that. So what we did, you can see, we connect the negative to the positive of the capacitor, and this negative we made as ground. On the other capacitor, the positive side made as the positive wire. So that's how we connect two capacitors in a series. We're gonna charge this capacitor and we're gonna discharge using this LED. Connecting the negative to the negative of the battery and positive to the positive terminal of the battery. Now this capacitor is charged. These two capacitors are in series. Now I'm going to discharge to this LED, connecting positive to the positive of the LED and negative to the negative of the LED. So that's it. The total capacitance decreased. The LED turned off very fast after turned on. So that's how you connect capacitors in series and in parallel. I just want to show you the equations of capacitors very quickly. So this is our capacitor, two plates, basically two metal plates separated by a small distance, and the space is filled with some kind of insulator. It can be just air is an insulator, or some kind of plastic, polyester, ceramic, whatever. So these capacitors are polyester capacitors. The space between these two plates are filled with polyester, and they're like ceramic capacitors like these. These capacitors are ceramic. Two plates of the capacitors are separated by a ceramic material. And in electrolytic capacitors like this is a huge electrolytic capacitor. Working is same, two metal plates or metal foil. This has aluminum foil separated by plastic, and also paper, and the space between two plates are filled with some kind of electrolyte. But electrolyte is not an insulator or anything. It's actually acts as an electrode. I'm not going into detail of electrolytic capacitor anyway. Maybe I can make another video at some time. Okay, so these are two metal plates separated by a small distance. Whenever we apply a voltage, these two plates will get charged. One plate will get charged negatively and the other get charged positively. For example, if I connect the negative terminal of the battery to this plate, this one will charge negative, and positive, the other plate will charge positively. If I connect a voltage source like that, negative terminal, positive terminal of the battery. That's how capacitor charges. There's an easy formula, equation to find the total charge stored in a capacitor, which is Q, that's the total charge, is the capacitance C into voltage applied. As I showed you earlier, we applied a 3 volt to like a 4700 microfarad capacitor. So in this case, the capacitance is for 4700 microfarad. So 10 to the power of -6 farad multiplied by 3 volt. So that would be whatever the value of this, that would be the charge stored in this capacitor. And the unit of capacitor is coulomb. What's the spelling? COULUM. The coulomb. That's the unit of capacitor. Charge. Electric charge. So that's how you find the charge stored in a capacitor when we apply V volt to a C capacitor or C capacitance. So when we connect two capacitors in parallel, just before I showed you two capacitors will be like that, connected in parallel, and we connecting the positive to one end and the negative of the battery to the other end. Say the capacitance of the first capacitor is C1 and the second one is C2, then the total capacitance will be C is equal to C1 plus C2. If there is another capacitor C3, connected in parallel, total capacitors will be C1 plus C2 plus C3. Another capacitor, fourth capacitor, then it will go like C4. So the total capacitance will be sum of each capacitor's capacitance. Then that is series, that is parallel when we connect the capacitors in parallel. If it's in series, like that, first capacitor, second capacitor, third capacitor, then the total capacitance C can be found from the equation 1 by C is the total capacitance is equal to 1 by C. C1, C2, C3 are the capacitance. 1 by C1 plus 1 by C2 plus 1 by C3. And if we connect another capacitor in series, 1 by C4. It goes like that. Then from this equation you will be able to find the total capacitance of the capacitor. Okay, that's all I want to talk about today. In the next video, I just want to show you how a capacitor charges, what happens if we apply, if we include a resistor in the circuit. It's quite interesting. That is the